Okay, we have here another interesting integral. We have the integral from 0 to pi of cosine to the 10th x over sine to the 10th x plus cos to the 10th x dx. Okay, this is actually a problem I just did on the other channel like a week or so back. And for some reason I wasn't that satisfied with that other video just because it's like a 5-second method and a 10-minute video. So in this video I want to take a more direct approach and probably a shorter video. Okay, and to get started with this, I just want to use this fact that we have on the board here in blue. And I actually just did a video recently on why this is true and how this works. So if you have any questions on this, I'll provide a link to that other video if you just want to see how this comes out to pi over 4. So notice what we have here, the exponent's just n, so it's going to work basically for any exponent. In our specific case here, we're saying n is going to be equal to 10. So this would work and this would be pi over 4, but the only issue we have is our upper bound here is not pi over 2, it's pi. So that's the one thing that we need to deal with. But if we can get it into one of these forms, we have something that we know is going to be pi over 4. So next what I'm going to want to do is a substitution, and I want to do something to get my bound down to pi over 2, and so we'll just do, so what I want to do is set u equal to x minus pi over 2, and then just solving for x, that's going to give me x is going to be u plus pi over 2, and finding my dx value, taking the derivative, that's just going to be du. So when we make this substitution on this, we'll plug in pi minus pi over 2, is going to give me pi over 2 for my upper bound. So that's exactly what we wanted. Then 0 minus pi over 2 gives me minus pi over 2 here. And then for x here, we need to plug in this. So we're going to end up with cosine u plus pi over 2. Here we're going to have a sine u plus pi over 2. This value is going to be the same thing as this, so we'll just copy this down here. But now for each of these values for cosine and sine, we're just going to use a formula to simplify these. So for these values on the right, you could find these pretty easily just using the angle addition formulas for cosine and sine. I'm just going to plug in my values. Now first for cosine u plus pi over 2, we have minus sine of u. But because it's to the 10th power, that's an even power. So what we're going to end up with here is just sine to the 10th u. And then we'll do the same here as this is the same value. And then for sine u plus pi over 2, it's going to be cosine, so we're just going to end up with cosine to the 10th u here. But now at this point, what I want to notice is that this, what we have right here, this is actually an even function. So then I have this property over to the left for even functions. For our f of x, assuming f of x is even, and we have symmetric bounds around 0, then we can just bring a 2 out front and we can change the lower bound to 0. Now how do I know this is an even function? Well, cosine is even, so that's good. Now sine is odd, so technically if you plugged in like minus u here, you'd bring a minus out front. But again, because we have the even power, it's just going to make the minus sign go away. If you just plugged in a minus u to this whole thing, all the minus signs will go away and you'll get back the same function. That's our definition of even. So now we'll just rewrite this and we'll bring that 2 out front. We'll change the lower bound to 0 and rewrite the whole integrand. But now by doing that, we just recognize that what we have here, this integral, it's actually in this form right here. In this case, our n value would be 10. And so we can say that this value is going to be pi over 4. So what we have here is actually pi over 4. So all we need to do to finish this off is we have our 2 out front, we just multiply it by pi over 4, and we'll have our final solution of just pi over 2. Okay, good problem. We'll stop it there. Thanks everyone for watching. Have a great day.